afternoon, everybody. We continue with our supplier management lecture. Today is 14th of October, and we continue with our inventory control strategies. And we will look at two methods today. One is the single period inventory model, or also called news vendor model. News from newspaper. And the second one is the inventory review systems. Okay, so let's look at each of these methods. So one single period inventory model. So definition: the single period inventory model, also known as news vendor model, is designed for managing inventory in situations hold on a second. ¿Me puedes traer un poco de agua, por favor? In situations where there is only one opportunity to sell the product before it either perishes or becomes obsolete. Okay. The goal of the single period inventory model is to find the optimal order quantity that balances the risk of stock out with the cost of overstocking. Okay. So examples include newspapers, because unsold copies have no value after the day ends, or perishable goods, items like fresh or baked products, goods, or seasonal products. Like, I don't know, Christmas decoration or fashion trends or limited editions. Okay? So, does it make sense so far? So, we need to focus on two types of costs. One, the under age cost, also called sortage cost or CU. This cost is incurred when you run out of stock and cannot meet demand. Okay? It includes the lost profit and penalties or customer dissatisfaction. Okay, so this is the underage cost. The second is called the overage cost. Or excess cost. Or CO. This cost is incurred when you order too much and are left with unsold inventory. Okay? It includes holding costs, disposal costs, or obsolescence costs. Okay? So, CU and CO. Questions on this? So, the underage cost or CU is equal the selling price minus the cost per unit. Okay? selling price minus cost per unit. And this represents the profit you lose for each unit of demand that you cannot fulfill. Okay. And overage cost CO is the cost per unit minus salvage value. Okay. This represents the profit you lose for each unit of demand no, sorry. The loss you incur, sorry, I jumped lines. Just losing, I'm reading my notes. Sorry. Represents the loss you incur for each unsold unit accounting for salvage value in example resale or recycling or markdown or scrapping or something like that. Okay. So, any questions on this? So, critical ratio. Or CR. This is also important. To balance these two costs, we use the critical ratio, which determines the optimal service level. Okay. The critical ratio is the ratio of the CU to the total cost. Okay. CR is CU divided by total cost, which is CU divided by CU plus CO. Okay, so how many times? The critical ratio is how many times the CU is contained into the total cost. And the critical ratio helps decide how much of the demand distribution we want to cover. In other words, it provides the probability that the optimal order quantity will meet demand. Why is that? If CO is 0, this means we don't have any overage cost, okay? Cost per unit equals the salvage value, then CR is 1, meaning 100% probability to meet demand. Okay? If CO is 1 or is much bigger, say much bigger than CU, then CR tends to 0. So 0 probability to meet demand. Okay? Questions, please? Okay, I need some feedback, thumbs up. Everything okay? Yeah? Good. So please be on time when we have the lecture, because I cannot look and write and see if somebody's waiting in the lobby, okay? Please be on time. So, question is, how do we find the optimal order quantity? Q star, okay, is determined, Q star is determined by the critical ratio once CR is calculated. It corresponds to a set score from the normal distribution, which helps find the point of the demand where we should place our order. Okay. So if the demand, which is the assumption, okay, if the demand follows a normal distribution, and we assume this always with known mean value and standard deviation, the optimal quantity is given by Q star equals mu plus Z times sigma, and being Z, the Z score corresponding the critical value. We saw already that our critical value is a probability, okay? So if the critical, the critical ratio, not the critical value, critical ratio. If the critical ratio is, let's say, 0.87, mu is, let's say, 2, and sigma is 1.5, then we go to our statistic table. We saw this the other day. Insert picture from photos and get that there. Okay. So we look for 0.87 somewhere. Where is it? Somewhere here. Okay. So it's 1.13. The Z score is 1.13. So our Q star with these values is 2 plus 1.13 times 1.5. Can somebody do it for me, please? And have a Can somebody do it, please? Thank you. 3.695. Okay. So this is the way, it's easier than using differential equations because we have the assumption that our demand is distributed normally. So, questions please? Let's look at an example or problem statement. You manage an inventory for a bakery. Of course, in the exam, I don't tell you that I am talking about the model SPIM, single period inventory model. You need to know because of the problem statement, okay? So if I talk about a bakery, you manage the inventory for a bakery that sells fresh croissants each day. With this sentence, you already need to know we're talking about SPIM, okay? So the selling price is €3 per unit. The cost of production is €1 per unit. Okay? Unsold units, croissants, can be sold to a recycler for €0.20 each unit. Okay? Daily demand follows a normal distribution with mean value 200 units and standard deviation 30 units. Okay? So calculate Q star. Okay? So the first step is to calculate CU, it's cost per unit, minus selling price minus cost per unit. This is a no-brainer, it's €2, okay, per unit. 3 minus 1. Second is calculate CO, is cost per unit, minus salvage value. Meaning €0.8 per unit. 1 minus 0.20. Step number 3 is calculate CR, is CU divided by CO plus CU. So we have 2 divided by 2.8. Can somebody do it, please? Well, I do it 0.714. Okay? The fourth step is to calculate the set score. If you go to the table as above, this table I would give in the exam, so no worries. The set score 0.714, 0.714 is somewhere here. Okay, so 0.57. Okay, so the set score is 0.57. In the exam, you need to mark, okay, the values also like I am doing now. Okay, so please remember that. The fifth step is to say, okay, Q star is the mean value plus Z times sigma. So it's going to be 200 plus Z 0.57 times sigma 30. Going to be somewhere around 218 units. So, are we cool? Yeah, anybody has questions? So, we should sell 218 sur order, not sell, order 218 units each day to balance the risk of stockouts with the cost of overstocking. Okay? Questions? Any questions? Please give me thumbs up if no questions. Yeah. Okay. What about the rest? Yeah. All right. Well, let's continue then. So we go to the second point of today. Which is the inventory review systems. Okay. The next challenge is to manage inventory over a longer time horizon where products have a continuous or repeated selling period. Okay? Just like we said before, imagine the Christmas time or imagine some auction where you offer certain products. So, two main systems. Are used to monitor inventory and decide when, how much to order. One is called continuous review system, or depending on Q and R parameters, we will see now. And two is the periodic review system, also called TS. Okay, we will see what this means in a second. Both systems have advantages and disadvantages depending on the nature of the system, of the business. And we will see that as well, okay? So allow me for deploying these two systems in a way that we can follow. So let's say we go on for the 2.1, the continuous review system. QR. We call this continuous review system, okay? In a continuous review system, the inventory is reviewed continuously, of course. And an order of a fixed quantity Q is placed as soon as the inventory reaches a reorder point, which is going to be R. Okay, this is the system we saw the other day, and with our EOQ, remember the EOQ models, okay? So the key features is inventory is tracked continuously. An order is placed when inventory reaches the reorder point, which is calculated to ensure stock, and the quantity Q is fixed, typically based on the EOQ model. Okay. So this is based on the EOQ calculations that we already know. See lecture on, I think what was the 1st of October. I don't recall it exactly, but I think it was the 1st of October. Okay, let me double check on the GitHub in parallel. supplier management. Yeah, no, it was not the 1st of October, it was 30th of September. Okay? So I don't repeat it because it's the same. We have certain assumptions there, and sometimes we only look at Q, sometimes we look at other variables depending on the assumptions we make. Sometimes it's just one variable. With the supplier model we have two variables. With the manufacturing model we have again two variables, and yeah, we made all the assumptions there that are necessary to calculate the economic order quantity and the reorder point. Of course, if you have questions, you can always ask, okay? And 2.2, which is a little bit more on the context. I want to give you a bigger context than the other day. Is the periodic review system. We look at TNS, is PRS system here. In a PRS system, inventory levels are reviewed at fixed intervals, not continuously. You can say weekly or monthly or whatever. And an order is placed to bring inventory up to a target level. Okay. One example would be the one thing we will look at later on, which is a variation of Kanban, Conwip, or even Kanban. You know, you bring to a certain target level. Unlike the continuous review system, where you place an order as soon as the reorder point is reached. Reached. Here you review and replenish the stock only at the end of the review period. Actually, let me put this away. I'm not going to give examples yet. I don't want to advance anything yet, so I'll just leave it blanco. Okay. So inventory is only reviewed at set intervals, let's say weekly or monthly. The order size varies depending on the stock level. So you want to go to a target. If you have 10, you want to get to 100, you order 90. If you have 20 and you want to go to 100, you order only 80. More safety stock is required compared to the CRS system, because the system does not react immediately on demand fluctuations. Okay, so here is remarkable. We need, so be aware with PRS systems, we need more stock than with CRS systems, because PRS does not immediately react to demand fluctuations. Okay, this makes sense? Yeah. All right, so let's continue with the mathematical formulation. We have the parameters review period, which is T, okay? It's the time interval between inventory reviews, revisions, and 2, we have the order up to level, so the level of inventory that we want to reach after the inventory level to which stock is replenished. At each review. So the amount of order Q equals S minus I. S, we know what it is, and I is the current inventory. I is the current inventory. Okay, at the time of review. And we have a problem, an example. There, so QS minus I. Of course, I depends on the demand, and it has, okay. So let's assume you manage the inventory of laptops with following characteristics. Average daily demand, 10 units. Lead time, 5 days. Review period, 20 days. Safety stock, 50 units. So the first step is calculate S, okay? The order up to level. So the order up to level S must cover the demand during both lead time and review period. So the time it takes for the laptops to get to the factory, to the customer, and the time it takes to review. So S equals demand times L plus T, okay? Demand is measured in units per time. This is the lead time. Measured in time, and this is the review period, also in time. So we have units there. Plus double S, where double S means the safety stock. Okay. So meaning S equals D, demand 10 units per day, times L 20 plus 5 plus safety stock, which is did I give, yeah, safety stock is 50. Okay, so we get a total of 300 units. The second step, after we have S, is to determine Q, the order quantity, which is Q is S minus I, and is 300 minus 120, 180 units. Okay? This is just an example. You need to remember, of course, this formula, okay? S equals demand multiplied by lead time plus review period plus the safety stock. Okay, so we have now two methods. We have the continuous review and the periodic review. Let's compare them, okay? 2.3. No. Wait. Yeah, we have the continuous review and we have the... Let's compare them. as we promised. Okay, so 2.3. Comparison. Continuous review system and periodic review system. Okay. So let's make a little table. Future. CRS, QR, PRS, TS. Okay. So from the perspective of monitoring, the CRS is continuous. Okay, it's in real time. The PRS is periodic. It's in intervals. The second feature is the order trigger. Here is when inventory reaches reorder point. And here is at the end of review period. Okay. Then the order quantity here is basically the EOQ model. In here is variable depending on the stock levels at the review. Here the safety stock is lower. Inventory is closely monitored. And this is higher. Reviews are less frequent. Hallo? Alles klar? So, and then complexity is higher because constant tracking and here is lower. Is simpler to manage. Okay. And the risk of stock out is lower due to constant monitoring. And here is higher because you can't run out between reviews. Okay. So the conclusion is the single period inventory model or the news vendor model is ideal for managing products with short life cycles or perishable goods. Okay, and 2 is the inventory review systems. Either CRS or PRS, focusing on different and ordering approaches, monitoring and ordering approaches, suited for various operational context. So there is not only one single solution. You need to know what you do in order to choose wisely.